So micro-frontends in the wild. I talked about micro-frontends a lot already, so I thought of changing the title to In the Wild. Usually it's called A Strive for Fully Verticalized Systems. And one thing which all of my talks have in common are the first three questions I ask the audience, because I want to get to know the audience, and I want to know who knows micro-frontends, who knows what this is all about. Just a few of you, okay. Who uses them in production? Okay. Who regrets to use them in production? Okay. Cool. First things first, my name is David Leitner. I work for an Austrian company based in Vienna called Square Solutions. We do a lot of technical consultancy. So, for example, micro-frontends, microservice architectures. We do a lot of agile transformation. This is what I will not touch in this talk. We do a lot of software delivery, so we provide high functional and high efficient teams, and we do a lot of upskilling, so we try to really give the experiences we make in our projects to the outside world. That's why I'm, for example, here to talk at conferences. This whole story started in 2014 with this great book, Building Microservices, from Sam Newman, who is now in the next room, I saw. So I'm quite surprised that still so many people are here, even if Sam Newman is speaking in another room. And Sam Newman did a great thing with this book, yeah? Because till then, it was not really clear what microservices are about. I went to a lot of conferences in this time, and people always ask me, okay, how big should a microservice be? What is the difference between service-oriented architecture and microservice architecture? So it was really unclear what is this whole microservice thing about. And this book, for me, and I think for the whole industry, made it a little bit clearer, created a common understanding of the term microservices. And what Sam Newman actually said is, microservices are small and focused on one thing to be autonomous, right? So this was the definition Sam Newman brought about microservices. So even the definition of microservices seems to be micro, right? And at this time, lots of companies started to build microservices. We saw pictures like this from Amazon or Netflix, and many more started to go into this approach of building microservices to be autonomous, right? This was the idea. This is why we did this. So why did we want to be autonomous? Roughly there are six good reasons why we want to have autonomous microservice architectures. The first one is the obvious one. We want to have independent deployments, right? We want our services to be independent deployable. Let's say we just change one service. This one service should be deployable independently. There are still lots of companies who say that they are building microservices, but they cannot independently deploy the services. They have this kind of monolithic deployment where they deploy all the services at once. This is not microservices, this is distributed monoliths, right? And this is a big, big problem because this comes with the disadvantages of monoliths and comes with the disadvantages of microservices just in one architecture. So if you go for microservice architecture, you have to be able to independently deploy things. The second one is distinct operation. So each service runs on its own, so has persistence on its own, starts on its own, dies on its own, restarts on its own, right? So it's fully autonomous in its runtime. The third one is that we can be technology agnostic. We don't have to, but usually it's a very good thing that we can build services, this is very loud here, that we can build services in frameworks and technologies that fits the problem best. That's a very good thing we got from microservices. The fourth one is that we have small interface surfaces, so usually the amount of APIs we expose from a microservice API is quite limited. We just give a very, very exclusive amount of APIs and publish it to the outside world. We can model around business domains. I will not go into detail about the whole Blue Book thing and whole domain-driven design thing. But of course, this is one of the advantages we got there. And we can parallel development. We can parallelize development, sorry. And this is important because software eats the world, right? We are building tons of software each day. We need to parallelize this stuff. So these are roughly the 6 reasons why we do microservices. And this is why the today's blueprint architecture looks somehow like this, right? Microservice architectures everywhere. We build new projects with microservices. We start to migrate monoliths to microservices. And beyond those microservice architectures, we usually have something like this. We have a single page application. This one can be written in Angular, Vue, React, whatever you prefer. And in between, we have a gateway which connects those microservices with our single page applications. And there's a first disclaimer here now, okay? In 80% of the use cases, that's fine, okay? In 80% of the use cases, this blueprint architecture works totally fine. For the rest of the 20%, I will tell you how we could maybe improve the situation. Because why did I tell you all this microservice information? Or why did I give you this introduction to microservices? I guess we at NEC London, most of you know microservices and know the advantages of microservices. But if we now consider the single page application, and again take a look at those 6 points I mentioned earlier, we will see that we have huge issues here on the front-end side of our application, on the front-end side of our architecture. So we don't have independent deployments. We can just deploy the whole single-page application, or we can deploy nothing, right? So it's binary, 1 or 0, deploy it or not deploy it. Of course, we can work with feature dockers. We can do all these things, but we do not fulfill these very important characteristics of independent deployments on the front-end side. We don't have distinct operations, so if something breaks on the front-end side, the chances are high that our whole front-end breaks. We cannot be technology agnostic. I was at the biggest Angular conference in 2014, NGConf in Paris, and I was a huge advocate for Angular back then. And I was really looking forward to this conference. And the first thing I heard at the keynote was Igor Miner going to the stage and saying, okay, AngularJS will not be supported anymore in the future. And this is the first time when I said, okay, maybe being technology agnostic will also be great in the front end. Because we still have to fight with this decision that we have a lot of legacy AngularJS applications which we cannot migrate to Angular. There's still not a real good migration path from this whole big legacy AngularJS applications to the newer version of Angular to maybe a different framework. So being technology agnostic could be also important in the front end. We do not have those small interface services as we have these monolithic front ends. We cannot support parallel development. That's the most important point. This is when people usually come to us and say, hey, David, we have now 6 developers working on our front end. We cannot scale this up. They're stepping on each other's toes. We cannot put more developers into those teams. So we don't have the possibility to really parallelize this front-end development. And this is usually when the pain starts. And this is usually where people say, okay, front-end monolith is born, right? And as we usually do with front-end monoliths, or with monoliths in general, we'll kill them with something that starts with micro. And in this situation, we kill it with micro-frontends. And this is all you usually hear about and say, okay, we split our front-end application into smaller chunks, into smaller single-page applications, and that's it. These are micro-frontends. So I made it in 20 minutes. Oh, 10 minutes, actually. and this is really the thing. This is where many talks about micro-frontends already end again. They tell you then, okay, you can do this in Angular, and you can do this in Vue.js, and this you could do in React, and this you could do in the framework of the month. But that's not about micro-frontends, right? The interesting question which appears here is, how do you split those micro-frontends up, right? How do you do this? Where do you find the right boundaries? And this is very similar to microservices, where we had the same problems in the beginning, where we didn't know how to slice them, how big they should be, because we asked the wrong questions. So the question is, how do we slice those micro-frontends into the right bundles? And it turns out that there are, of course, multiple possibilities to do this. The first one, the most obvious one, is that we say, okay, we do really fully end-to-end verticalization. So let's consider this Amazon domain or this e-commerce domain where we say, okay, we have a catalog, we have ordering, and we have a profile. So catalog shows all the products, right? Ordering shows you the current orderings, and you can process orders there. And the profile allows you to change your name, your profile picture, your address, all those things, right? And then we say, okay, looks good. Looks like 3 totally separate bounded contexts maybe. We just slice them like this, and we just connect them by hyperlinks. This is a very easy approach, right? To slice our application into smaller chunks. And one application which is doing this actually extremely good, in my opinion, is Amazon, right? So the same domain. And you see on the left-hand side, the product details page. On the right-hand side, you see the ordering page. Sorry, it's in German, but I still think it's visible. And the interesting thing about Amazon is if you hit the search page for the first time, and if you finish the ordering, you actually go through 7 different applications. You go through 7 different applications, and they look totally different from time to time. You see it on the UI elements. You see it even of the fonts. You see it on the header. Those are these are 2 total different headers, right? And you sometimes even see it on the logo. They use different logos on different applications. Because they just say, okay, we cutted it into smaller applications and we just connect them by hyperlinks. It's the easiest thing you can do. This kind of hyperlink connected applications. And if we take a look again at the advantages, we say, okay, we now have independent deployments. I can deploy the profile without deploying the ordering. We have distinct operations. If the profile fails, the ordering will still work. We can be technology agnostic. As I said, we can build this one in React and this one in Angular. We have small interface surfaces, so we just have a hyperlink. That's the smallest interface surface you can get, right? That's the highest decoupling you can achieve in the web development world. We can model around business domain, and we support parallel development, so all done, right? But this assumption has one basic flow, right? It's based on the idea that we have fully verticalized systems. And everyone who is working, I don't know, more than 24 hours in software engineering knows that's usually not the case, right? We have some cross-dependencies between those services. And a very, very good example for those cross-dependencies is usually the dashboard, right? Sorry. Because dashboards love to break service boundaries. That's their favorite hobby. And if you take a look at this, for example, the dashboard maybe wants to show the latest products, wants to show your current orderings, and wants to show your profile information, right? That's quite natural, I would say. And if we do this, we have 2 main problems. The first one is overfetching, and the second one is over-requesting. What does this mean? So let's assume we have a dashboard and it shows good morning or good afternoon, David Leitner. So we need the first name and the second name. And we fetch the first name and the second name from the user microservice. And the user microservice returns us a profile with 40 fields, right? We use 2 of them, first name, last name. Maybe it returns us a gender, maybe it returns us some kind of address and some kind of other user information. So we get 40 fields back, use 2 of them, so we overfetched 38 fields. And if we do this at scale, this becomes a huge problem in huge architectures because we do a lot of overfetching. Because we have very generic domain services in the background, but we have a very consumer-driven API, of course, in the front end. The second one, even worse, is over-requesting. So let's assume you want to show the latest orderings on the dashboard. So the latest 3 orderings. So you fetch the latest orderings. You get 3 of them. You want to show maybe some product information to the ordering. So you take the product ID from the ordering and fetch the product information from the product services. So you do 3 requests to the product service for each ordering. And then maybe you want to see the delivery status. So you fetch based on the ordering ID the delivery status, right? So you have 7 requests to just show the 3 latest orderings. And this is what we usually tend to call over-requesting. And these are both very huge problems in big applications, which make them very imperformant. And people start to blame then RESTful APIs mainly for this kind of situation, but that's not the fault of REST APIs. It's just wrong usage of REST APIs, right? Because REST APIs were made to provide generic APIs. They were not made to provide consumer-driven APIs as we would need them here. So we could, of course, start to implement here some kind of extra API, extra endpoint for the dashboard, that this usually results in a lot of orphan endpoints and a lot of duplication in the endpoints, and it's hard to maintain those services. So another approach, or maybe better approach, which we usually tend to follow then, are so-called backend for frontends. So each frontend has its own microservice, which actually does exactly the aggregation as we saw before. So the aggregation is not happening on the client side anymore. The aggregation is done on the backend for frontend. So if the dashboard, for example, needs this information now, the aggregation is done exactly by this backend for frontend. And there are 2 important things we observe in the wild about backend for frontends. The first one is, if you think very abstract of software engineering, I would say there are 4 layers, right? So we have some data layer, we have some persistence layer, where we fetch data and where we save data. Then we have some kind of domain logic, where we say, okay, I don't know if this person is older than 18 years, it can order some kind of special products. And then we have some kind of process flow. If this service says A, we go to this service. If this service says B, we go to this service. So based on the process flow, we can fulfill some kind of user flow through our application. Then we have the presentation logic, where it's all about bringing data into the right shape so that we can visualize it on the front end. And it's very, very important, it's really very important to understand that the backend for frontend is just about this presentation layer, right? So you should not put any kind of domain logic or process logic into there. Why? Because otherwise you will end up again in the application, because these backend for frontends are just used by this frontend. They are just here to transform generic domain service APIs into consumer-driven APIs. That's their job. It's really just shuffling data around, aggregating data, and bringing it into the right shape. And the second important thing to understand is that the backend for frontend and the frontend itself are one deployable unit. Even if they run on different systems, because the one runs on the client, the other one runs on the server, they are one deployable unit. And we see very often in the wild now that people start to split this up. People say, okay, Java developers do this, JavaScript developers do this. But then you lose most of the benefit, right? Because the idea is here that if I need here a special API, I just say, okay, let's go there, add it here, let's fetch the data, and we're done, right? You should never split those two things up. This is one thing. It's just part of the front end on the backend side. It's like a port on the backend so that we can avoid over requesting and over fetching. Another thing we see quite often these days is that people start to use GraphQL instead of backend for frontends, which is, from our point of view, a quite good approach, because GraphQL allows you just to do presentation. So it's very opinionated, it's very hard to put process flow and domain logic into GraphQL. So this is why we think it's a good idea to use GraphQL on this side of the application. And this is how we can solve these issues of over-requesting and over-fetching when it comes to hyperlink integrated applications. But there's always a but, right? And if you hear but, you know, okay, everything you heard so far was useless. It's not like this, but of course, I mean, it's obvious, right? Hyperlink integration breaks a single-page application. That's clear. You go to the server, you have all these round trips, so you lose this fluent flow of Angular, of Vue.js or React, whatever you use a single-page application framework. The idea of single-page applications is not to go to the server and to follow each hyperlink and to jump from application to application, but it's about providing a fluent flow for the users. So this, of course, breaks by hyperlink integration. A second problem is that we introduce a horizontal layer, and this is a very important point in my opinion. Because if you take a look at this view aggregation layer, it's a horizontal layer in our architecture, right? And we wanted actually, when we started to build microservices, our goal was to go away from these horizontal layers because they have one important downside. If you want to change something here, you need to change it here and you need to change it here. That's what we call the ripple effect, right? This is why we started to verticalize our systems. That's why we shouldn't separate based on technical concerns, we should separate based on domains, because we wanted to avoid this ripple effect. We have it back, and even worse, we have this kind of horizontal layer which will affect one change with multiple results, right? So if we change this service, the chances are high that we need to change the ordering and the dashboard service, for example. And this is the problem of those horizontal layers, and we get them back if we go for backend for frontends, of course, because we have one indirection which tends to be horizontal. And the third thing is it only works on a very coarse-grained level. So you can go for hyperlink integration, but it will just work on a very coarse-grained level, right? Not everybody of us is building applications as huge as Amazon. And for smaller chunks, it's usually not possible to really slice it up in a way how we would need it for hyperlink integration. So maybe let's rethink this whole idea of Micro-Frontend and let's take a step back. let's assume we could do something like this. We could have a dashboard microservice which provides the frontend on its own. So it returns the frontend. And then we have a profile microservice which provides a special view for the profile, which can be then, for example, embedded into the dashboard. And we have the same thing for a catalog, and we have the same thing for orderings. So we have two different definitions of microservices. We have this one microservice per page approach where we just link by hyperlinks, and we have this idea of having multiple micro-frontends per page. And for me, the second one is usually the stuff I mean when I talk about micro-frontends. The first one is just linked applications, but I'm not religious about this term. It's not my intention. But this causes a lot of confusion. Then Abramov, for example, the inventor of Redux, just said he doesn't understand micro-frontends. Yeah, and I think this is basically because we don't have a common understanding what we are talking about when we are talking about micro-frontends. Right? Multiple people use micro-frontends, but all use them differently. So we have those two definitions. We have the one where we say, okay, we just link applications together, and we have another one where we say, okay, we have really multiple micro-frontends per page. So let's talk a little bit about the second approach, this one here. Again, the same question, how do we integrate them, right? How could we integrate those different micro-frontends per page? And the next slide is, I think, the most complex I ever created, yeah? Please stay with me. I will try to explain it as good as possible. So let's assume we have micro-frontends. We have 3 of them. So we have 3 repositories of micro-frontends. And the easiest thing we could do is we just take all them and bundle them together at build time. We take those 3 micro-frontends, bundle them together to one deployment monolith, deploy this thing, and then the client fetches the whole application once it hits our edge side services. That's what we tend to call build time integration. So we integrate those micro-frontends together at build time. Another approach would be server-side integration, where we have, again, those 3 micro-frontends. We build them independently, we deploy them independently, and once the client hits our edge-side service, we start to bundle those micro-frontends together to one application and provide the client this one application. And the last approach would be that we say, okay, we again have 3 micro-frontends, we build them independently, we deploy them independently, and the clients can fetch them independently, and the aggregation is done in the runtime, right? So these are actually the 3 options we have. I don't say that one of them is better or worse, but these are the 3 options we have. So let's talk about all of them in detail a little bit. So build time integration is definitely the easiest one, right? This is the easiest approach you could go for. You say, okay, we have those 3 applications. Usually you do something like putting them into one monorepo. So who knows what a monorepo is? Few of you, okay, great. So why do we do this? Why do we put things into monorepos? Basically for 2 reasons. It allows us extensive code sharing and reuse. So let's assume we have a button and we want to use the same button in all our micro-frontends. So we put all the micro-frontends in one repository. We would put the button library in the same repository, and we can easily share this button between those micro-frontends without the version conflicts and the burden of distributing libraries. So if we would not go for a monorepo there, we can change the button. We need to push the button. We need to go to all the micro-frontends, increase the version, and get the latest version of the button. So this is why we tend to use monorepos there. Many companies use them. Google uses them, for example. Google has one company monorepo. Facebook has the same, and other big companies. But it's important also to mention here that those companies invest a lot in tooling. So it's not just that they have one big Git repo lying around somewhere. So they have a lot of proprietary and own written toolings for those monorepos. But even if we're not Google or Facebook, we can also use monorepos. There are tools, for example, NRVL, which tended to be more Angular focused, but these days it's a monorepo tool to be technology agnostic, so you can also do it with React, Angular, in common even. So if you want to go this road, NRVL is a good fit. Maybe if you just say, okay, you anyway just use Angular, you can use Angular workspaces, which provides a monorepo feature out of the box more or less. Or you could go with something which is called Learner, which is again a more complex way of managing monorepos, so you can even have different versions of your libraries, for example, within one monorepo. And this idea of monorepos is not new, to mention this again, yeah. For example, if you take a look at the Mozilla Firefox source code, you will see that this is a monorepo. The whole Firefox is bundled up into smaller modules, so each module has its own folder in this monorepo, but the whole application is in one repository, right? Even if different people are working on different modules, it's in one repository. And the big advantage is that they always can ensure that if they change something, they will not break any dependency because they just have one version always, and they are always on the latest and greatest. So this is the advantage of monorepos. That's why we usually tend to do this when we do build-time integration. And if we take a look at this now, and again, those 6 advantages, we now have independent deployments, still not, right? Because we cannot independently deploy one of those micro-frontends. We can just build them all together, but we cannot independently deploy them. We do not have distinct operations, so usually this can be an issue here. So if the frontend is broken, the chances are high that everything is broken. We cannot be technology agnostic, but we support smaller interface surfaces. So as I mentioned, we have dedicated modules, we have dedicated frontends in our repository. These are real dedicated and autonomous applications. We can model around business domains, and the most important part is we can support parallel development. So when we split our application into smaller applications, smaller libraries by using, for example, Angular workspaces, this usually helps a lot in parallelizing our front-end applications. But that's maybe not enough for us, so let's take a look at the second option, server-side integration. I will share the slides anyway, so you don't need to take photos of the slides. Server-side integration, there are a lot of projects. I think the most famous or the most well-known one is Project Mosaic from Zalando with its Tailor. Does anybody notice here? Okay, cool. So Project Tailor is built up on server-side includes. And server-side includes are a very old technique, and they look like this. So you have in your HTML some kind of includes, and they are at server side. So when you hit and when you fetch the HTML, they are resolved. So in this situation, you would go to the product microservice and would fetch the products for you. You would go to the payment microservice and would fetch the payment view and so on and so forth. And this server-side includes or edge-side includes. These are two different technologies which follow actually the same or fit the same purpose for this goal. For example, used by IKEA. So IKEA is just building the application by following this idea. They just use server-side includes and integrate it all together on the server side. Tailor from Zalando and many other frameworks build up on these techniques. So it's really server-side or edge-side includes under the hood, but they of course allow to make this a little bit easier. And Tailor calls itself a layout server. So the idea is that you provide a layout for each route where you can go to. So for example, you hit the edge service, you say, okay, I want to see the dashboard. Then the Tailor server says, okay, let's try to find a layout for the dashboard. Or we have one, right? And then we have multiple fragments in this dashboard. We can see this here. So for example, we fetch the header from our header microservice. We fetch the catalog from our catalog microservice. We fetch the account from our account microservice. And we really fetch this from those microservices, right? We do not do anything here. We just go, okay, say, give me please the HTML, which I can include here as fragment. And Tailor comes with a few nice goodies. For example, it has this primary attribute where you can say, okay, the catalog defines, for example, the HTTP status code. So if the product is not found in the catalog, and if the catalog returns 404, this whole page will return 404. Or it has something like async. So when we don't get some account information, we say, okay, it's async. So we return the page without the account information, and we will load it afterwards once we have it. So Tailor gives us this mechanism. And it also provides us fallback sources. So let's say this account fragment or this account microservice is, I don't know, built up on a legacy system, and there are some downtimes from time to time. So we can just say, okay, we have a fallback source. So we go to some kind of static HTML and say, okay, the account information is currently not available, but the rest of the application is working. So this is helping us in building resilient micro-frontends. And of course, you can then define multiple templates for multiple routes, and this is how it's usually working. Yeah? The problem with Taylor is that it's a little bit out of support, in my opinion. There's not much movement in this project, but the good thing that there is a multiple other libraries which nearly work the same way. For example, Podium or Open Components, which fulfill the same goal actually. They are all based on this kind of architecture that you aggregate on the server side based on a specific route. Good, then let's go into the last one. No, let's go back to the 6 last points, right? So what do we have now? We have independent deployments, right? We can deploy those micro-frontends independently. If I change this micro-frontend, I can independently deploy it. That's a huge thing with server-side integration, right? We have distinct operations. So as we saw with this fallback URL, right? Or with this fallback source, when this one is failing, we can still be resilient. We can return a frontend. We can say, okay, maybe this part is not available, but the frontend is not broken. We can be technology agnostic. I didn't mention this, but for example, Project Taylor has ways to isolate JavaScript and also CSS. So we can really build those applications into different technologies if we want to do this. And we support small interface surfaces again. We can model around business domains and we support parallel development. So this seems to be perfect, right? Well, it nearly is. We still have this issue of round trips, right? We have a lot of round trips because every time we need to change something on the page, we need to go to the server and fetch a new page. So let's check the last one. Let's check runtime integration. As we said, at runtime integration, we build those micro-frontends independently, we deploy them independently at the browser, they are aggregated, right? And we do this usually by something which we tend to call aggregation UI. And this aggregation UI provides us routing templates and lazy loading, so it's quite similar to what we saw before on the server. It's based on routes, and based on routes we provide templates, and with these templates we load micro-frontends then. And there is a ton of frameworks actually which support us in doing this, and they are based upon iframes. This was the older frameworks, used iframes for this. Everybody hates iframes now, so we tend to use web components. Does everybody know web components? Okay, for those who don't know them, it's like iframes in cool, I would say, yeah. So they provide some kind of similar isolation, so you can actually extend the DOM with your own elements, and they give you quite good isolation like iframes. And there are frameworks which actually are built up on web components or iframes like single SPR, meta SPR root or micro-FA, and they tend to call themselves meta frameworks. So frameworks that allow you to aggregate multiple frameworks. And I think meta framework is a really heavy word, yeah. As I said, a meta framework is a framework to handle multiple frameworks, right? And this is what those frameworks are called. And to be honest, we are also somehow guilty because we did something similar, yeah? In our company, we built some kind of meta framework also, which allows us to aggregate different micro-frontends at runtime, yeah? And those meta frameworks, as mentioned, they are doing one thing. They are aggregating the different frontends together. And in particular, they have a few core competences, right? And the first one is, for example, isolation and composition. So it allows us to isolate those different micro-frontends and compose it together at runtime. The second one is routing. So based on the route, we provide different aggregations, so as we saw on the server side. And the third one is messaging and shared state. So usually you want to have some kind of messaging between those micro-frontends on the client side. So for example, if somebody wants to buy a product, this must be known by the ordering micro-frontend. So these are usually the things which those frameworks bring you. And we were thinking about this, and we were a little bit of unhappy of our current solution. We said, okay, let's rethink this. Let's say, okay, we have those different frontends, and we want to aggregate them. But we don't want to have this meta framework because we don't want to have this vendor lock twice, right? Because here you have a vendor lock on the meta framework level, and even on the framework level. So it's kind of heavy, kind of fat. We didn't want to have this. So we thought about, okay, how can we solve this? How can we solve this just by utilizing the web platform? And it turns out that the web platform is quite mature when it comes to these things. So isolation and composition, as said, since a few years, we have now web components. They are now also actually supported by most browsers. And there are polyfills for most other browsers. So we can support it down till Internet Explorer 9, which is in most of the cases good enough for us. So we can say, okay, we can just do the isolation composition by web components, right? So we just use web components to get this job done. The second thing is routing. So how do we achieve the routing? Who takes care of the routing? Who takes care of which web components to load now? And there's a nice library which we found, which is the Vaadin router. I don't know if you know Vaadin. Maybe people from the Java background know Vaadin. It was a huge, or is still a huge framework in the Java world. And it switched a few years ago from GWT to web components, so it contributes a lot to the web component community. And one thing they contributed is a router which is based on web components. And this one looks like this. So you just import your router, say, okay, into this outlet I want to load my router, and then you define routes, right? This looks like a React or an Angular router. And the thing is that you define a route, and based on this route, you load a web component. So as I said, web components are just extensions of the DOM, so they are just real. They just look like native components. And then you say, okay, based on this path, we call a web component and load it there. Yeah? And this Vaadin router has a few really nice features. For example, lazy loading. So it allows us to lazy load bundles once we hit the special route. So if you go to a user profile page, we can start to load the user profile bundle, which then provides the web component for the user profile view. So we said, okay, let's go with this tiny small library, Vaadin router, for routing, right? And then we had the last point, messaging and shared state. So as I mentioned, usually you want to share state between those micro-frontends on the runtime, right? Because you say, okay, I don't know, you add a product to the cart, so you need to inform multiple micro-frontends that you currently did this. And there are multiple approaches how you achieve this. So one is, for example, providing a global Redux store. So one big Redux store where all micro-frontends can access. This can be useful. In most situations, I think it's an overkill. So what we tend to use here is we just use normal streams. So for example, RxJS streams, where we say, okay, we provide central streams for all our micro-frontends where people can subscribe and publish messages. Or even more isolated, we say, okay, each micro-frontend provides its own stream and it publishes messages there. And these streams are immutable, so you cannot publish messages from the outside, sorry. You can just publish messages from the micro-frontend. So in this situation, we have a mutable stream on all our micro-frontends, and if somebody else is interested in the information of another micro-frontend, it just subscribes this immutable stream. So you usually have those three options. Some kind of global state management like Redux, and global event stream, which you can achieve with RxJS, or these immutable streams which are provided and just for subscriptions from the micro-frontends. And with this, we just have two really, really small dependencies, which is a web component router and which is an RxJS library for streams. And they allow us to actually achieve all what we got before for meta frameworks. And if we think about this now, and that's a very interesting thought in my opinion, then this index HTML is becoming the environment, right? So, for example, what is Kubernetes for our microservices is the index HTML for our micro-frontends. And all we need to do then here is we say, okay, all our micro-frontends, all they need to provide is just a web component, right? So if we add another micro-frontend, it just needs to add another web component. We can add it to the router, and we can, of course, or it can, of course, access our shared state. So that's our contract, a web component, which we can then easily integrate. And then people are asking, okay, where to put the framework here, on the environment or on the micro-frontend? And this is a very, very common question we get, and I think it usually depends on the framework which you're using, right? If you, for example, go for something like Angular or React or Vue.js, which are quite heavy frameworks, you usually would put them on the platform. You would say, okay, the micro-frontend can expect there's Angular 8 available on the platform right now. If you say, okay, you don't want to have this, you want to be fully technology agnostic, then you usually go with different frameworks. You go with micro frameworks. You go with very, very small things like Svelte, or Stencil or Sketchers, so which are just frameworks, a very low abstraction above web components, which just have a very, very tiny size once they're compiled. With Angular Ivy, maybe we can also move Angular here up to there, but for now, in my opinion, it's too big to provide it with every micro-frontend. This will kill your performance. So if you go for bigger frameworks like Angular, I said, we usually move it to the web platform, to the environment. And if we go for really tiny, small frameworks where we say it's important for us that every team can use a different framework, that we can really stay decoupled there, we usually tend to go with those micro frameworks like Svelte or Stencil. So these have one thing in common. They are actually just web component compilers, right? They just provide you a more neat way to create web components. And once you compile, then you have native web components, and you don't have much of an overhead during runtime. So our environment is the index.html. This is very important. And if our environment is the index.html, there's another very, very beautiful idea, in my opinion, which is called immutable web apps. Anybody ever heard about immutable web apps? Okay. So immutable web apps are inspired by 12-factor apps. Who knows 12-factor apps? No, okay. 12-factor apps are 12 rules to build maintainable microservices. So these are 12 rules people came up to say, okay, this is how our microservices should look like. For example, one rule is that the environment should provide the configuration. So one rule of 12-factor is the environment is injected from the outside by environment variables. So your microservices are not built with some kind of configuration to get it at runtime from the environment where they are running. And for example, this idea of providing environment variables is also used in web applications where we say, okay, our environment, as mentioned before, is the index.html. So we define here an object which is called env, which provides all the configurations at runtime. So once we build our micro-frontends, we don't need to know anything. We get this from our environment. We get this from our index.html. A second idea, for example, from 12-factor app is that we clearly define our dependencies. We clearly say, okay, we have a dependency on this service in this version. And the same thing is what we do for immutable web apps, where we say, okay, we define here exactly which micro-frontend and which version we want to use. So we have a list here of all the micro-frontends we currently use, and you can easily adopt them and update them by just going to the environment and saying, okay, we use now the user profile micro-frontend in version 2 instead of version 1. And this is immensely powerful, following this idea by understanding that the index.html is the environment of micro-frontends if you go for one-time integration. So let's go one last time through those points, right? We have independent deployments. We can achieve this with runtime integration, of course. We have distinct operations. As we've seen, we have the possibility with web components to create some kind of isolation that allows us to have distinct operations. We can be technology agnostic. It depends which framework you use. As I mentioned, I would not use Vue.js and Angular on the same page. This is just too heavy, right? You will kill all your mobile users. You usually don't want to do this, but you can. You have small interface services, you can model around business domains, and you can support parallel development, right? So again, all the 6 advantages. Which one to use now? Build-time or runtime integration, right? I give this presentation a lot at clients, and they usually ask me, okay, that's all nice, so which one to use now, right? And the proposal I could then make is, it really depends on what you try to achieve. If you want to go for classical request response models, where you say, okay, I do a request and I get a view back as a response, right? Then of course server-side integration is maybe the more natural fit. And the important thing about server-side integration is that the integration, the interaction between those micro-frontends is done on the server side, right? So if they need to share some kind of information, that's always done on the server side. But if you want to go for long-living applications where you want to have this fluent single-page application feeling, of course you need to go for runtime integration. And the big difference is here that the interaction between those micro-frontends, as we saw, is usually done on the front-end side. So there's some kind of shared global state, there's some kind of event bus or some kind of stream, right? And this is more the question, where do you want to have the complexity of integration? And is it important for you to have a fluent feeling? Oh, some examples. So as we saw, this is, for example, used by IKEA a lot, by Zalando Rewe Group, it's a German company. And runtime integration, you see at DESN, for example, Spotify or Deutsche Bank. So there are companies doing both things. Right? There's not a better or a worse case. It really depends on what you want to do and where you actually want to have the complexity. And it's a question of usability then at the end. Right? So what did we see? We saw 4 different kinds of micro-frontends. We saw the first thing, which is called hyperlink integration. We saw runtime integration, server-side integration, and runtime integration. Sorry, build-time integration, server-side integration, and runtime integration. And then again, as I said, I do this talk quite often at clients, and then they ask me, okay, thanks, yeah, what to use now, right? You're not here to provide more questions, you're here to provide answers. And I think the first very important thing, and I tried to tease this with the disclaimer in the beginning, is to understand, and I love this definition of saying microservices bias options, right? There's this fantastic definition about microservices which says microservices bias options, right? And the same thing is for micro-frontends. Micro-frontends bias options. And the bias, the options as we've seen, right? The bias independent deployments, they provide us the option of distinct operations, they provide us being technology agnostic, they provide us small interface services, they provide us to model around business domains, and they provide us parallel development. But as I said, they allow us to buy options. And the important thing is not here options, the important thing here is here buy. Because we buy these options with a lot of complexity, right? That's the trade-off. We buy, for example, independent deployments by using micro-frontends with a lot of complexity. And this complexity, for example, is UI UX consistency. If you go for micro-frontends, it's much harder to achieve a consistent UI and UX because you have this kind of distributed applications. It's really hard to ensure that everybody is using the same button in the same font size. That's one of the complexities you get. Or shared state, as we've seen before. It's not easy, right, to achieve something like shared state on the front-end side. This is very complex. You need to think a lot about the synchronization and how to restore those states once the application is closed and opened again. Resilience is a big topic, as in microservices. Resilience is a huge thing. How do you achieve a resilience in the distributed front-end application? Tracing and analytics is a big challenge because currently you just usually have one application which you easily can trace, but if you have multiple components per page, it's getting hard to trace them and do the right analytics. Offline first, if you want to go for progressive web apps, don't go for micro-frontends, right? These are unsolved problems. You cannot really go in an offline first approach if you build micro-frontends. And lots of more things. So it's really of buying options. You can get all those options, or you can just take 2 of them, but it will cost you some complexity. It's always in trade-off. But let's assume you say, okay, we want to have independent deployments, that's very important for us, and we want to have parallel development, right? Those are the 2 things we want to have. Then say, okay, it's fine, then let's go with micro-frontends. Then again the question, which one to use now, right? I told you already I want to buy those options, which one to use? And it hurts. I know it hurts to say this, and it even hurts me to say this, but all I can really then do is refer my favorite book, right? If somebody asks me which one to use now, right? Because it really depends, right? Even if it's so hard to say again and again, but it really depends, right? And it's so super important to understand, and this is the most important thing you should take of this talk, is that there is no silver bullet when it comes to micro-frontends, and there is no one size fits it all. It's all about mixing and matching, right? So let's assume again that we have this application with a landing page, with some kind of shop, and with some kind of ordering. So 3 maybe quite good decoupled bounded contexts. We could say, okay, let's give it a first try. Let's go with hyperlinks. That's a super nice option. Let's say, okay, we start here with hyperlinks now. But maybe the shop is still too complex for one team. Maybe you still want to have some kind of parallelization or resilience there. Then you say, okay, let's split up the shop further. Let's go here for runtime integration because it's very important, right, that the application still feels fluent, that the ordering process is very important for our customers. So we say, okay, let's go for runtime integration there. And maybe the ordering is also still too complex. Maybe it's too complex for one team to handle this whole order process. And maybe we have to talk with a lot of, strange old systems, and it's kind of kinky stuff which you usually need to do with ordering. So maybe we go here for server-side integration because it's not so important anymore. The customer already bought the product. We can have a couple of round trips now. So it's really about mixing and matching, right? Those options I showed you, and based on your application, based on your domain, based on your problem you have at hand, you really need to find the right mix here. I cannot give you the fulfilling answer here maybe, but really be creative. Try to understand your domain. Try to understand how you can cut your application into smaller frontends. And there's one final secret I want to share with you. And maybe it seems to be obvious, but I think it's very important to understand. And this final secret is micro-frontends are distributed systems. Who knows the one and only definition of distributed systems? Nobody? Again, it's important to understand, first of all, that if you build micro-frontends, you build distributed systems in the frontend, okay? And the one and only true definition, at least for me, for distributed systems, is that everything that can go wrong will go wrong, right? And keep this in mind. Keep this in mind. And we see a lot of clients now starting with micro-frontends from scratch, right? And saying, okay, we will build this with micro-frontends now, and we will start immediately with going into a micro-frontend approach. And this is usually this creates a lot of pain. So maybe if you create new applications or if you think of going the micro-frontend approach, maybe start with a monolithic first approach, right? Thank you. I hope this was useful. Any questions? Yes?
When you're doing these isolated applications, presumably each of them has got its own isolated styling.
Yeah.
But for years, we've always been told you should have styles, your top level cascading down to all your components. So if you want to change what the font of a P did, then you can just do it in one place and it cascades through everything.
Yeah.
So you've got these two competing things. You've got one defined in one place and cascades through everything, but isolated in
the question was if global styles are a good thing, right? In a more abstract way, I would say, should we have some kind of global styling where we define, for example, default fonts and things like this? Well, I think what we currently do in front-end engineering and why we use all these single-page applications is because we want to achieve component-driven development, right? We do not build pages anymore. We build smaller components and aggregate them together to huge applications. That's what React, that's what Angular brought us on the table. And I think based on this idea of component-driven development, this whole idea of styling changed a lot because back then we had separation of concerns. We said, okay, the styling is in one file, the HTML is in another file, and for example, the JavaScript is in another file. But now that the separation is a little bit different, in my opinion, because the separation is based on components, and the component itself should bring the style, should bring the JavaScript, should bring the HTML. So what we usually tend to do if we go for micro-frontends, that's actually a big topic which I didn't even open, is of course some kind of design system, some kind of component libraries, which are used then by different micro-frontends and which then allow us to ensure that we have a consistent UI and UX. So we, for example, have a container component which comes with the default font size, which comes with some kind of header information, and we have, for example, a button which comes with some kind of styling. So we do not have any global CSS anymore because we usually want to avoid this. But there are companies who do it differently. So, for example, the Gmail, right? Gmail had a big redesign last year. All they did is they changed CSS, right? because they didn't touch anything of the HTML and JavaScript, they just changed the CSS. But I think this is more the oldish way, because it's not really the component-driven way, and usually you have one component which comes with styling and comes all those things, so you usually don't have, at least not a huge global CSS anymore. Okay? Yeah?
I'm wondering about when you said you used Angular on the actual, what did you call it?
Yeah.
Your own,
The web platform.
how does that even like work with the, what do you actually use Angular for in that?
Well, no, we don't use it, we just provide it. Actually, we don't use it in this layer, we just ensure that every micro-frontend which is provided can ensure that there is an Angular instance on this application. Do you know what I mean? We just provide the dependency once. Because you could also say, okay, each micro-frontend comes with its own Angular version, but this is usually from application size a big problem. So that's why we provide it once, and everybody says, okay, I can be sure that there is Angular available at runtime for me.
Yeah, the actual Angular library.
Exactly.
Yeah, so, but if you have like a cached object in one of your micro frontends and you start the other one and you go back to the other one, is it still?
It's one single page application. So they share one Angular framework. They share one index HTML. So it's really one instance which is running all the time. And maybe you lazy load some micro frontends, but it's still on one instance always running. That's about runtime integration. It's really like ASP.NET, just with separate web components in our case. Okay? If you have any further questions, reach out for me via email, or I'm here, I think, tomorrow and Friday. So we can also have a chat during lunch or something like this. Cool, thanks.